All right, so welcome back. So we've already looked at resistors, we've looked at capacitors. Now let's look at inductors. Now, when we talk about inductors, they are also an electrical component of devices, and they are very important in electronics. So inductors are coils of wire that temporarily stores electrical energy in a magnetic field. Remember that I told you that capacitor will store there. So I told you that capacitors will store charges in an electric field. In what? In an electric field. But for inductors, they do so in what? Inductors do so in a magnetic field. So you have to take note of the difference between them. So they are all storing charges, but one will store eight charges in an electric field, and one will store eight charges in what? In in a magnetic field. All right. So with that in place, now inductor is also a passive electronic component. Passive electronic component. So just as I said, it will store electric charges, or it will store charges temporarily in a magnetic what? Field. So if you look at the diagram, this is a typical example of what? Of an inductor. In terms of circuit diagram, you can have it as this to be your what? Inductor. Now, inductor also has the ability to resist changes to current, and that is what we call the inductance. So that ability, when measured, the it is called the inductance, and it's measured in Henry, capital H. It's measured in Henry. Now, when the source of current is removed, the magnetic field of the inductor gradually would collapse, and it begins to what? Discharge its what? Current. So initially, it is storing the charges in the magnetic field. So we connect it to a source of power. So let's say this is my power source. Now charges are flowing. This power nature produce the electric field. So they produce the electric field. Sorry, the magnetic field, I mean. So this coil produce the magnetic field. It's produced the magnetic field, and it will cause charges to be stored in there. Now, when this power source is removed, the magnetic field will collapse. And in that state, the inductor begins to dissipate the charges it has stored up. The charges stored up. As simple as that. Now, the amount of inductance, just as I indicated, the inductance is the inductor's ability to resist changes to current. So the amount of inductance depends on six major things. So let's look at the six major things it depends on. One is what? The amount of current. The amount of current flowing through the inductor, amount of current flowing through the inductor. Then two, it also depends on the number of coil turns. The number of coil turns. So if I have an inductor that has several number of coil turns, it means that its inductance is also going to increase. Then three, it also depends on the diameter of the coil. The diameter of the coil, very important. Then the number four is the spacing between the turns. Spacing between the turns. So I want you to go and find out if they are evenly spaced or they are evenly spaced, what will be the influence on the inductance, and if they are densely packed, so they are very close to each other, I want you to also look at what would happen in that situation. Then also, it also depends on the size of the wire used in making the inductor. Then the last one is the type of material. So at times we can put a conducting material within the loops or the coils. So the type of material inside the coil. Now, if I have inductors that are close to each other, closely placed inductors, and one is connected to a power source, the charge that is built up at one side will be transferred to the other side. And this is the theory behind how transformers work. So transformers are like two inductors placed close to each other. So just as one stores the charges, it's transmitted to the other inductor and it conducts. Now we need to know some. When we were looking at capacitor, we said that when the capacitor is connected to a DC power source, is going to store electric charges. But when it's connected to AC, current will flow through it. There's not going to be any storage of electric charges. In inductors, when you connect it to an AC power source, charges will be stored. But when you connect it to a DC a DC power source, this is what will happen. The inductor or the wire of the inductor momentarily will assume or behave like a short circuit. So it will behave like a short circuit, and it will allow a lot of electric current to flow through it. So in that case, charges will not be built up, but it will allow electric current to flow through the inductor. So I think we'll end it here. The next thing that we will talk about is transformers, how transformers work, and we'll look at some calculation under transformers. We look at the primary voltage, secondary voltage, primary turns, secondary turns. We look at the step up, step down transformers and others. So make sure you watch the next video. Bye bye.